Virtual networking in Azure allows you to create isolated networks within the cloud. These networks can be customized to meet specific requirements such as security, performance, and scalability. Virtual networks, VNets, are the foundation of Azure's networking capabilities, enabling resources like virtual machines, VMs, to communicate securely with each other, the internet, and on-premises networks. Understanding how to configure and manage these networks is crucial for any Azure administrator. Network routes determine how data packets travel from one network to another. In Azure, routes are used to direct traffic between subnets, VNets, and external networks. By default, Azure creates system routes to manage traffic flow. However, there are scenarios where you need more control over the routing paths, which is where user-defined routes, UDRs, come into play. UDRs allow you to customize the routing behavior to meet specific needs, such as directing traffic through network virtual appliances, NVAs, or VPN gateways. User-defined routes, UDRs, provide greater control over network traffic, enabling you to optimize performance, enhance security, and ensure compliance with organizational policies. For example, you can use UDRs to route traffic through a firewall for inspection, direct traffic to a specific VPN gateway, or isolate traffic within a VNet. By configuring UDRs, you can create a more efficient and secure network architecture tailored to your specific requirements. To configure user-defined routes, you first need to create a route table in Azure. A route table is a collection of routes that define how traffic should be directed. To create a route table, navigate to the Azure portal, select Create a Resource, and search for Route Table. Provide the necessary details, such as the name, subscription, resource group, and location. Once the route table is created, you can start adding routes to it. After creating a route table, the next step is to add routes to it. Each route consists of an address prefix, a next hop type, and a next hop address. The address prefix specifies the destination network, while the next hop type indicates where the traffic should be directed, e.g., virtual appliance, VPN gateway, internet. The next hop address is the IP address of the next hop. By adding routes to the route table, you can control the flow of traffic within your virtual network. Once you have configured the routes, you need to associate the route table with one or more subnets. This association ensures that the routes are applied to the traffic within those subnets. To associate a route table with a subnet, navigate to the subnet settings in the Azure portal, select the route table you created, and save the changes. This step is crucial for enforcing the custom routing rules defined in your route table. Azure supports several next hop types for user-defined routes, each serving a different purpose. The virtual appliance next hop type is used to route traffic through a network virtual appliance, such as a firewall or load balancer. The VPN gateway next hop type directs traffic to a VPN gateway for secure communication with on-premises networks. The Internet next hop type sends traffic to the Internet, while the VNet peering next hop type routes traffic to a peered virtual network. Understanding these next hop types is essential for configuring effective UDRs. Consider a scenario where you need to route all outbound traffic from a subnet through a firewall for inspection. To achieve this, create a route with the destination address prefix set to 0.0.0.0/0, which represents all IP addresses, and the next hop type set to virtual appliance. Specify the IP address of the firewall as the next hop address. Associate the route table with the subnet, ensuring that all traffic from the subnet is inspected by the firewall before reaching its destination. In some cases, you may need to isolate traffic within a virtual network to enhance security. For example, you can create a route that directs traffic between subnets through a network virtual appliance, NVA, for monitoring and control. By configuring UDRs to route traffic through the NVA, you can enforce security policies and monitor traffic flow within the VNet. This approach helps in maintaining a secure and compliant network environment. Monitoring and troubleshooting user-defined routes is essential to ensure that your network operates as expected. Azure provides several tools for this purpose, including Network Watcher and Azure Monitor. Network Watcher allows you to capture and analyze network traffic, diagnose routing issues, and verify the effectiveness of your UDRs. Azure Monitor provides insights into network performance and helps identify potential issues. Regular monitoring and troubleshooting help maintain a healthy and efficient network. When configuring user-defined routes, it's important to follow best practices to ensure optimal performance and security. Some key best practices include keeping routes simple and specific, avoiding overlapping address prefixes, regularly reviewing and updating routes, and using network security groups, NSGs, in conjunction with UDRs to enhance security. Additionally, document your routing configurations and changes to maintain clarity and facilitate troubleshooting. Following these best practices helps create a robust and manageable network architecture. Advanced routing scenarios may involve complex configurations, such as multi-tier applications, hybrid cloud environments, and cross-region traffic management. For example, you might need to route traffic between different regions for disaster recovery or load balancing purposes. In hybrid cloud environments, UDRs can be used to manage traffic between on-premises networks and Azure VNets. Understanding these advanced scenarios and how to configure UDRs accordingly is crucial for managing sophisticated network architectures. Configuring user-defined network routes in Azure is a powerful way to control and optimize network traffic. By creating and managing route tables, adding routes, and associating them with subnets, you can customize the routing behavior to meet specific requirements. Understanding next hop types, monitoring and troubleshooting routes, and following best practices are essential for effective UDR configuration. Whether you're routing traffic through a firewall, isolating traffic within a VNet, or managing advanced routing scenarios, UDRs provide the flexibility and control needed to build secure and efficient network architectures.